When we're talking about producing sound, we're talking about, like we talked about, the speaker cone pushing air molecules. Here we're talking just a little bit about hearing sound. It's just a short little blurb um, from our textbook about this. There's a hearing test, and again, you can find all kinds of different hearing tests. I don't know if any of these links will be active when you're watching this video, but there's lots of different hearing tests online, and you can kind of see how low can I hear and how high can I hear. Something to remember when you're doing those hearing tests is your like cell phone speakers or your computer speakers. They may not be great. They may not be good enough to actually produce the sounds that you think you're supposed to be hearing. So get a really good pair of headphones if you're going to do one of these online hearing tests. But something that we know is sound is a longitudinal vibration in a medium. Okay, what that means is we've got sound waves as they travel through air. We've got sort of these compressions and rarefactions. The audible region, you'll hear slightly different values in here, but it's around 16 hertz to 20,000 hertz. Sometimes you'll see 20 to 20,000 or something like that. The reason there's a range is because everybody's ears are different. So it's roughly in this range. What that means is the lowest frequencies that we can hear are somewhere around here, and the highest are somewhere around here. Generally speaking, when you're born, you kind of have a full range of hearing. And as you get older and older, you start to lose, especially at the high end. You tend to lose that. Now that we're all listening to headphones all the time, our hearing is all getting worse. I'm sure that we are all losing this faster and faster. Infrasonic is anything outside of the range on the low side. So anything below 16 hertz, kind of 15, 14, 13, something like that. It's called infrasonic. It's too bassy, it's too deep for us to hear. The human ear just can't vibrate that slowly, and we kind of lose out on hearing that. And anything that's outside on the high end, anything that's greater than 20,000 hertz, 20 kilohertz, that's called ultrasonic. If you've ever heard of going for an ultrasound, like in a hospital or something, that's what they're using. They're using some frequency outside of human hearing. A dog whistle, if you've ever seen that or heard, well, probably not heard, didn't hear it, but if you've ever blown a dog whistle, dogs can hear higher frequencies than humans. So a dog whistle is designed that you can't hear it, but a dog can hear it. Same thing with bats. Bats make sounds kind of way up here. Generally speaking, we can't hear them, but they can. When we're measuring sounds, we measure them in bells, and you may have heard of decibels. Decibels are just like using the metric system. A decibel, 10 decibels, is one bell. I don't know why it's BEL. It's named after Alexander Graham Bell. You'd think there'd be two L's up there. I don't know. Where'd the other L go? Who knows? But you commonly hear about decibels, and that's 10 of those make up one bell. So one bell is actually quite loud. Here's a freebie for you. I'm never going to ask you these questions, but here's the decibel scale. 0 decibels is actually not no sound. It's not silence. 0 decibels is supposed to be kind of on the verge of being audible. So if you have a really good set of ears on you, you should just start hearing sound somewhere around 0 decibels. But a really sensitive microphone could actually pick up things that are less than 0 decibels. Okay, so the way the decibel scale works is 0 is not no sound. A very quiet sound like a whisper is 30 decibels. Normal conversation is all the way up to 60. So you can see we've had a big jump here up to normal conversation. The decibel scale is like a logarithmic scale, and what that means is we're going to have smaller number jumps but bigger sound jumps as we go through this. Okay, so to go from normal conversation to busy traffic, that's quite a loud jump, but we're only going up by 10 decibels. And then to go from 70 to 90, like Niagara Falls, if you've ever been to Niagara Falls, it's pretty loud, or a train, so to go from 30 to 60, a whispered conversation to normal conversation, it's not a very big sound jump, it's a big decibel jump. Here to go from 70 to 100, so traffic to a train, that's a pretty big sound jump. And then we kind of go on and on up here. I don't know where hearing damage kind of starts. I think people often say like anything greater than 100 decibels is where you start getting hearing damage. So you shouldn't be exposed to it for long periods of time. And obviously the higher the decibels, the more damaging, the more quickly your ears can get damaged. So be careful with those headphones. Turn it down a little bit.